Hello everyone and welcome to the first session of thermodynamics subject, TMM 2673. Today I'm going to introduce you some basic concepts of thermodynamics. We'll learn about the pressure, temperature, units, and also the system, cycle, process, the process path, and so on. The objective of this session is to identify the unique vocabulary which is associated with the thermodynamics through the precise definition of basic concepts. Today's session is very important because it is the fundamentals of the thermodynamics, and we will need the definition and the basics which we learned from today's session. And also we will review some metric SI and English unit system. And next I will explain the basic concepts of thermodynamics such as system, state postulate, equilibrium, state or condition, process, and cycle. Moreover, we'll review some concepts of temperature, escape, pressure, absolute, and gauge pressure. This is also important later because we will use these units, these properties actually. Later we will see what is the definition of the property to solve the different problems related to thermodynamics. And also we teach you how to use systematic problem solving technique to solve different problems in thermodynamics area. First of all, let's see what is actually thermodynamics. Thermodynamics is the science of energy. In other words, any place we have energy, we may need to consider that as a thermodynamic system or thermodynamic problem. But before that, we should know what is energy. Maybe the understanding of the energy be a little hard because it is some kind of it seems to be easy, but not actually, because it is very broad and general topic. So, but by definition, we call the ability to cause changes as energy. So anything which has the ability to cause changes, it has energy. And to go in more detail about thermodynamics words, it comes from the two different Greek words, as you can see here. Therm, or which means heat, and dynamics, which means power. So thermodynamics is actually the science of heat and power, and sometimes we call thermodynamics as heat and power science. And there is some principle and rules later we will see in more details, but generally one of the most important laws or rules for this science is the conservation of energy principle, which says that during an interaction, energy can change from one form to another, but total amount of energy remains constant. Here you can see an example. As you may know, we have two different types of energy. For a stone on an height, so you can see here it has 10 units of potential energy, but because it is not moving, it doesn't have any kinetic energy, so it has 10, you can imagine it has 10 units of potential energy and 0 unit of kinetic energy, and total energy of this stone is, or this system, actually later we will see what is system, is 10 units. When it is falling down, the potential energy is converting to the kinetic energy. So as you can see here in this height, the 7 units of the potential energy is converted to the kinetic energy. But again, you should notice that the total energy is still 10 units. We call this conservation of energy principle, which forms the first law of thermodynamics. It says that an expression of the conservation of energy principle. The first law asserts that energy is thermodynamic property. As you can see here, it deals with energy. And the second law of thermodynamics, which is also important, is it asserts that energy has quality as well as quantity. An actual process occurs in the direction of decreasing quality of energy. In other words, in a system, always energy is going to be decreased. Until it reaches some equilibrium condition with its surrounding. Later we will see what is surrounding, what is system. But here is an example of conservation of energy principle for a human body. As you can see here, this guy receives 5 units of energy. 1 unit of energy is stored in the body of his body, and 4 units will goes out as energy out. Still, you can see the conservation of energy. 5 units in, 4 units out, and 1 unit is stored. So the total is equal. And in figure 1.3, you can see the figure to illustrate the second law of thermodynamics. As you can see here, heat flows in the direction of decreasing temperature. And as you know, temperature is thermal energy. So energy is going to reduce. So hot coffee here is 70 degrees Celsius. Surrounding is cooler, only 20 degrees Celsius. So energy from the higher energy place, or here from the place which is higher, will go through the lower, will transfer actually to the lower point of energy, lower point with lower energy, the point which has lower energy actually. And also we can consider problem related to the thermodynamics with 2 different methods, as classical thermodynamics and statistical thermodynamics. Classical thermodynamics is actually a macroscopic approach to a study of thermodynamics, and it does not require knowledge of behavior of individual particles. So we just consider the problem, thermodynamics problem, from a macroscopic approach. So we do not deal with atoms, molecules, or the particles actually of the substances. And it is useful because it provides a direct and easy way to the solution of engineering problems, and it is used in this text. It may have some error, but it is enough accurate to find the answer for our problem. And the other approach is statistical thermodynamics, which we go to detail of thermodynamics phenomena in a system. Based on this average, the behavior of large group of individual particles is considered, and but we don't use this technique in this textbook or in this subject actually. It is only used to support our finding from the classical thermodynamics. Any place we need to prove something which we get from this classical thermodynamics method or approach, microscopic approach, we will refer to the microscopic approach. But initially, we just use the microscopic approach to find the answer for that problem. But where is the application areas of thermodynamics? To be honest, it is, frankly said, we cannot find any equipment, any process which not consist of some kind of thermodynamics. As you can see here in our refrigeration systems, in boats, in aircraft and spacecraft, in power plants, in many other areas, we have some kind of thermodynamics. And this is the house you can see here, where any place which we have energy. Here is solar collector for the house, however may not very widespread, but if a house has the solar collector, it is related thermodynamics, hot water tank in the house, pump, heat exchanger in that water tank, about the shower as well. All of them are related to the thermodynamics. So it is hard to find equipment or anything which around us which is not related to thermodynamics. So all activities in nature involve some interaction between energy and matters. This interaction actually is thermodynamics. So it is hard to find an area that does not related to the thermodynamics. Here are some other examples. Human body also is the process. Our body also consists or involves some thermodynamics manner. You can understand, because we have energy, we have matter, we earn our energy by consuming different foods as our fuel. Actually, about the cars, it has energy to move its engine, wind turbine. It's produces energy by rotating its propeller. And air conditioning system, industrial applications, many other areas. It is very common and very general area, thermodynamics, and it is very important subject for especially mechanical engineering.